Next, let's take a look at CAMWORKS Turning Professional and the features and functionality that are included in this package. CAMWORKS Turning Professional includes all of the functionality included in SOLIDWORKS CAM Standard and Professional, along with the functionality included in CAMWORKS Standard and CAMWORKS Turning Standard. And it adds the Sync Manager to manage synchronous operations on mill turn and multitasking machines with multiple turrets and subspindles. Virtual Machine Standard, which provides machine awareness along with full machine simulation. Programming capabilities for mill turn and multitasking machines. And the ability to add either VoluTurn or prime turning by Sandvik at an additional cost. So now, let's take a look at CAMWORKS Turning Professional in action. Here's a mill turn part that we might want to program using CAMWORKS Turning Professional on a mill turn machine with a subspindle and dual turrets. So you can see this part has some wrapped features on it. It also has some work on the back side of the part, some drilled and tapped holes in the flange, and some boring that will need to be done from the back side. So there's quite a bit of work in this part, and programming this with a conventional CAM system would take quite a bit of time, probably an hour or more. But let's see how we can program it using CAMWORKS. So I'll go to the CAMWORKS feature tree, and my default machine is my mill turn machine. You can see the chuck there. There's also some stock that I have defined here, and you can see the stock being held in the chuck there. So let's start doing our programming. I'll begin by extracting the machinable features on the part. And then what I'll do is move this face feature. This is for the subspindle for facing the backside of the part once it's been transferred to the subspindle. I'll move that up in my operations tree. I'll also specify that I would like to machine the ID of the part, and I would like to do that using both the main and the subspindle. So I'm going to specify both here. Also, there's this group of holes here. These are the holes around the flange here. They are drilled and tapped from this side of the part. And so what I'd like to do is to move those holes down in the process. So I'll drag and drop those down at the end of the machining for the other side of the part. And I'll also specify that I would like those holes to be machined using the subspindle. And my library, I want to specify those are 6x1, M6x1 tapped holes. I'll say OK there. And then I'll go ahead and generate the operations for machining. And you can see how quickly CAMWORKS is able to generate the operations here. Then I'll go ahead and generate the tool paths. And now let's go ahead and run the simulation. Let me rotate the part a little bit. And then begin the simulation a second time here. So you can see the part being machined, the milling of the pockets here, drilling and tapping the holes in the pockets. Then the back side of the parts being machined using the subspindle. So these operations will occur on the subspindle. You can see the machining, and I'll go ahead and compare the machined model to the design model, and you can see that everything in green is net to the design model. There's some blue here. We have not machined the wrapped features yet, and you'll also see some red there for the tapped holes, and that is because the holes are modeled as the tap drill size rather than the major diameter of the tap. So hence they are in red. So now we have a good idea of how the part is going to be machined. And what I'd like to do is to optimize the program a little bit to reduce the cycle time. So let's do that next. Let's begin by going to the turn roughing operation up here in the operations tree. And let me go ahead and edit that operation. And what I'd like to do is to use pinch turning on this rough machining operation. So I'll turn on the simultaneous machining option here on this checkbox. And once I turn that on, you can see it instantly creates another toolpath for me and creates a pinch turning operation then using two tools, one in the top turret, one in the bottom turret, for doing the machining. And that means I could then go to the feed and speed tab, and here I can increase the speed significantly. So I'll basically double the feed rate here per revolution, and then go ahead and preview it. And now I can go ahead and run the simulation, and let's simulate the pinch turning here. You can see very quickly it is showing us two tools doing the turning now. Let me slow it down just a little bit and we'll see the two tools doing the roughing simultaneously using pinch turning. Okay, so now that we have the pinch turning added to the roughing operation, I might also mention that optionally you could add VoluTurn to do the roughing on a part like this. And if you want to learn more about the VoluTurn option, there's another video that you can watch on the VoluTurn. But for now, let's go ahead and now add the subspindle. That would be the next thing that we would like to do, is to grab the part with the subspindle and do the turning on the backside. So let's go ahead and add the subspindle op. I'd like that subspindle operation right here before the turning on the second side. So here I will go ahead and create the subspindle operation. And I want to do a standard transfer. And this dialog box then gives me the opportunity to program the subspindle. And you can see here where the main spindle is holding the part, then the subspindle is called, it orients and then rapids up to the part. And right here, what I'd like to do is to have that rapid a little further down the part. So I'm going to say minus 60 millimeters here. And let's enter that value. And you can see where it then goes over the part, and the part fits inside the chuck there, the hole in the chuck. So now I can go ahead and clamp the part. There we go. And then go ahead and back the main spindle off, and now this would then take the subspindle home. Now that we have our subspindle operation added, we can check to see that the subspindle is in place for this turning operation. Also for the milling operation here, we also want that subspindle in place as well, and you can see it there in place. So now that we've added the subspindle operation, we can go ahead and simulate again. Let's watch the simulation again. You see the pinch turning, and then you see the drilling and boring. Now it's doing the milling of the pockets on each side of the part and the drilling and tapping on the holes in those pockets. Then the subspindle comes up and grabs the part, takes it home, and then the machining occurs on the back side of the part using the subspindle. Okay. Looks great. And again, I can compare the machined model to the design model using this function. And you can see I now need to add the wrapped features. So let's go ahead and do that. We'll go back to the feature tree, and under this milling operation or setup right here, this milling setup, I would like to create those wrapped features. So let me go ahead and go to the wrap feature here and just select the bottom of one of those features. And for the end condition, it would be this diameter. and go ahead and create that wrapped feature. And that wrapped feature I'd actually like to do, let's do that first before we do the pocketing or other machining. So we'll do those wrapped features first. Also, what I'd like to do then is create a pattern of those. So I'm going to create a pattern here, which is be a circular pattern. Just pick the outside diameter here that I want to use as a circular pattern, and we want 6 of those. And you can see the features are highlighted there in green. Those wrapped features have been created. So I'll say OK. And then we can go ahead and generate the operation plan for those features. And for this setup, let's just go ahead and regenerate the entire setup here. And you can see those have been regenerated, and then generate the toolpaths for those. And now we can go ahead and simulate again. So let's watch the simulation here, the pinch turning, then the drilling and the boring of the ID. And here you can see the wrapped features being machined. And each one is roughed and then finished. So it's going around and finishing each of those as well. So you see the finishing operation here. And then it goes ahead and does the pockets and the drilling and tapping on the pockets as well. And then the subspindle comes up, grabs the part, takes it home, and the machining then is being done on the subspindle now. And then along with the finishing and the flange drilling and tapping as well. And now let's go ahead and compare the machined model to the design model. And you can see that everything is in green and that the part has been machined nicely to the design model. Looks great. Okay. Now, one of the other features, and important features that's available in the CAMWORKS Turning Professional is the Sync Manager. So let me open the Sync Manager. And here we can see the operations on the main spindle. And over here, you can see a little icon showing the operations on the sub spindle. So what I'd like to do is to move these operations on the sub spindle over to the front turret, so that the front turret will be used for machining the operations on the sub spindle, and the rear turret will be on the main spindle. And these operations will occur simultaneously. So again, reducing my cycle time and optimizing the part program. So I'm going to use drag and drop here to drag the facing operation over to the front turret. And I'll drag the finish operation, facing operation over as well. And then it will do the pinch turning on the main spindle. Both turrets will be involved in the pinch turning there. And then once that is complete, what I'll do is drag the roughing operation over, as well as the boring finish operation, and then the center drilling, and the drilling, and the tap for the M6 holes that are in the flange. So now that I moved all of the operations for the subspindle over to the front turret, let's go ahead and say OK here. And now it will regenerate the toolpaths for me. And if I go and change the display of the fixture, let me just turn it off for a minute and then go ahead and go to step through. And now we can see the operations occurring simultaneously on both the main and the sub spindle. So see the pinch turning here, and then you can see those operations that are occurring simultaneously on the two spindles. And we can see those synchronized operations occurring here. And I'll speed that back up. Okay. So hopefully you now have a good idea of how CAMWORKS Turning Professional can be used to program parts like these. Now, another great feature that's included in CAMWORKS Turning Professional is the ability to be able to do machine awareness, we call it. So if I go ahead and open up, and first let me turn on the fixture display so we can see our chuck again. Let's display it. And then go ahead and edit the machine. And here we can pick the machine for simulation. So I'm going to select the machine. And if I zoom out now, you can see where the part is being displayed in the machine that I would be using to machine the part. So this is a machine that includes a upper head and a lower turret. Let me turn that display back on here. And I now have this display components toolbar, which is part of the machine awareness. And now you can see the machine and the full setup along with the stock and the part being displayed, being held in the chuck. And we can really get a good idea of how that part is going to be set up on the machine. So hopefully I've given you a good overview of CAMWORKS Turning Professional, and we've looked at some of the options and features that are available for the product. And I think that about wraps it up. Thank you very much. For more information, go to www.camworks.com or contact your SOLIDWORKS or CAMWORKS reseller.